Continuing on with sample test 4, we're now dealing with situations where we don't have a common denominator. So what we want to see is how to make the two bottoms the same in the quickest way possible. Here one bottom is 2, the other bottom is 7. If we were to write out the multiples of 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And the multiples of 7, 7, 14, 21, 28. The first number I see that appears on both lists is 14. So our goal is going to be to turn both these bottoms into 14. On my 2 list, this was the 1, 2, 3, 4, 5, 6, 7 factor. So I'm going to be multiplying by 7 over 7. On my 7 list, it was the 1, 2 second factor. So I'm going to be multiplying by 2 over 2. 7 times x gives me 7x. 7 times 2 gives me 14. 16 times 2 gives me 32x. 2 times 7 gives me 14. When I now combine these two, 7x plus 32x gives me 39x over 14. I look to see if that can be reduced in any way. It can't. So I can just leave my answer there, 39x divided by 14. Here, for problem 12, I'm going to start with the numbers. So multiples of 4, 4, 8, 12, 16, 20. Multiples of 8, 8, 16, 24. Here's the first one that fits. So really just from a number standpoint, I'm going to be multiplying this by 1. I'm going to be multiplying this by 2, because again, it was the second multiple for this. It was the first multiple for this. When I look at the x's, I want to make sure they have the same power. So right now we have a squared here. To get this x to the same power, we're going to have to multiply by an additional x. So this second fraction gets multiplied by x over x. This first fraction gets multiplied by 2 over 2. When I do that multiplication, I need to make sure this 2 is being applied to both things on top. So 2 times x gives me 2x. 2 times positive 3 gives me plus 6. 2 times the 4x squared on bottom gives me 8x squared. For my second, x times x gives me x squared. X times 5 gives me 5x. On bottom, 8x times x gives me 8x squared. So now I have the same common denominator, 8x squared. If I combine the tops, the bottom is still 8x squared. The first top has a 2x, the second one has a 5x. The first top has a 6, the second one has an x squared. So x squared is going to be my leading term, the highest power of x. I can then combine the 2x and the 5x to get 7x. And finally, this 6 is by itself, so I get plus 6. You really can stop there, because it's as far as you can go. That said, I can factor the top. I can factor it to x plus 6, x plus 1. And I just want to do that to check to make sure that nothing cancels on bottom. It doesn't, so I would have been fine leaving it here. Final problem here, there is really nothing in common between x plus 2 and x minus 4. For that reason, I just have to multiply each fraction by the other. So the one that starts with x plus 2 on bottom is going to get multiplied by x minus 4 over x minus 4. The one that has x minus 4 on bottom is going to get multiplied by x plus 2 over x plus 2. In general, I think it's probably a good idea to leave the bottom factored because it might cancel something out at the end. So I'm not going to multiply out that x minus 4 times x plus 2. But on top, I am going to multiply these out. 2x times x gives me 2x squared. 2x times negative 4 gives me negative 8x. X times x gives me x squared. X times 2 gives me 2x. 1 times x gives me x. And finally, 1 times 2 gives me 2. When I combine the like terms on top, this 2x squared and this x squared give me 3x squared. This negative 8 and this positive 2 give me negative 6. When I add one more, I get negative 5x. Finally, this 2 is by itself, and it gets added at the end. On bottom, we have x minus 4, x plus 2, and I don't need to worry about factoring that top.